new formula today, and I think this is one that you actually haven't learned before. Regular polygons, remember, have congruent sides and congruent angles, and we are looking to find the area of these polygons. And the idea is that we're going to kind of split it into other shapes. So, I mean, you could think about splitting this one into a triangle and a trapezoid, or maybe into 3 triangles. But if we want to do a technique that works for all regular polygons, finding the center of that polygon and connecting to each vertex is the way to go. And the reason for that is because it creates congruent triangles. And then if we can just find the area of one of those triangles, then we can multiply and find the area of the whole shape. One measurement you do need to know, though, is the height of the triangle. And that'll be true for all of our regular polygons. We'll need the height of those triangles. You're not always going to see the shapes actually split up into triangles, but sometimes it will just give you that height. And that height is so useful, it actually has a special name. It's called the apothem of the polygon. Apothem. And I'm just going to straight up give you the formula. It's 1/2 the length of that apothem times the perimeter of the entire polygon. It's a capital P because you have to do a separate calculation to find that perimeter. This is the formula that always works, but of course we want to know why it works. And like I said, it's based on the area of each of those triangles. Now normally we're going to take the length of the side and the length of that apothem, and we would do 1/2 base times height. But that would just be one of the triangles. So then you'd have to multiply by how many sides there were, right? Since the number of sides is how many of those triangles we would have. So the formula I just showed you is a shortcut of this idea. You can see that the 1/2 is coming from the area of the triangle, 1/2 base times height. You can see how that apothem was involved. But then the perimeter of the triangle just comes from taking each side length times the number of sides. Wouldn't that be the perimeter? The side length times the number of sides. So these guys combined make the perimeter. So this formula based on the area formula for a triangle, but let's do some examples. So luckily this example, they gave us the length of that apothem. In our next lesson, we'll have some workarounds for that in case we don't know that length. But for today, we are just simply using 1/2 apothem times perimeter. Remember that that's a capital P because we have to do a little bit of work to figure out what the perimeter of the shape is. For this regular pentagon, we're just going to go 16 plus 16 plus 16 plus 16 5 times, also known as 16 times 5. So the perimeter of the entire pentagon is 80 units. So then to find the area, we will just take 1/2 the length of the apothem times the perimeter of the entire pentagon. And P.S., the 11 was measured in just length units, and perimeter is measured in just length units. So when we multiply units times units, we get square units. And that comes out to a total of 440 square units. And remember, that just tells us how many little squares it would take to cover this entire shape. For this lesson, I just want you to get used to using that 1/2 apothem times perimeter, but the trickiest thing you'll see is a shape like this where maybe it's not clear which number is the apothem. If it were up to me, the apothem would always be labeled going straight down to the midpoint of the side at a nice right angle from the center of the shape, right? That would be the apothem. But that 5.23 goes from the center down to one of the vertices. They actually call that length a radius of the octagon, or whatever regular polygon you're working with. But the apothem goes to the midpoint of the side. Now on a shape like an octagon, this 9.66 that goes all the way across can be split evenly, right? For example, if we put that 9.66 up and down, because of how an octagon is formed, we could just split that into 2 equal pieces, and that would give us the apothem. So in this case, the apothem is just going to be whatever 9.66 divided by 2 is, which is 4.83. 4.83. And just a reminder that that apothem helps us find the area of each of those triangles. But once we know what the apothem is, we're just going to use this handy formula, 1/2 apothem times the perimeter of the entire octagon. Well, I've got side lengths of 4. Since it's a regular octagon, they're all the same length. The perimeter then would be 4 plus 4 plus 4, 8 times, otherwise known as 4 times 8. We've got a perimeter of 32 units. And so this regular octagon has an area of 77.28 square units. I hope that made sense. And like I said, the trickiest thing you'll need to know today is how to figure out how long that apothem is in case they're giving you funny numbers on the diagram.